Welcome to another video. Here is a system of equations known as ODE, ordinary differential equation. But a lot didn't know where to start because many will come to the mind that is this an homogeneous or is this a variable separations? So truly this question is not easy to solve, but in this video I'm going to break it down on how to approach a question like this in any way you see it. Let's get started. So if you have this, we are going to make y uh, as the numerator as the y divided by the x. So we cross multiply and later divide both sides by the x. And here we have 4x plus y, everything raised to power of 2. The next thing to do here is, so it's not easy to separate this by cross multiplying by the x, so it's not easy to separate. But the best way to do is we let this one, the one in the bracket, I'm going to let it to be z. So if you have z equals to 4x plus y, and for this we have z, x, and y. So we are going to differentiate with respect to x. And this one is more of PDE, so partial differential equation, where we are going to be differentiating with respect to x. And here we have the z divided by the x equals to, I will differentiate x here, we are going to have 1, okay, and plus, if we differentiate y, we're still going to have 1, but we consider this as the y divided by the x. So since we consider x here as independent, so both two dependent, so we take the derivatives. And here we have the y dx. So I'm going to make the y dx the subject of the formula. So by transferring 4 here, and here we have this, the y divided by the x equals to the z divided by the x, then minus 4. And since we have the y dx at the top and we have make it to be equals to the z dx minus 4, so we are going to replace it in that equation above, and we are going to have the z divided by the x minus 4, everything equals to, and what is inside the bracket, we have let it to be z. We replace it as well with z, but everything goes to power of 2. All right, this equation is making sense. The next thing we are going to do here is we transfer 4 to other side, just to have the z, the x here only, and we are going to have z square plus 4. Then we can now apply the separation of variables. So since it's easily separate, we cross multiply, then we have the z equals to bracket z square plus 4, then everything in the x, and we divide both sides by x square plus 4. So since we have the derivative of z here, and by dividing through that, we have z square plus 4, we bracket it, and for this one as well, we have z square plus 4. And if these two go, we have the x only, and for this other side we have the z divided by z square plus 4, everything equals to the x. Then we want to obtain the value of z only, so we are going to take the integral of both sides. And by doing that, so we know that the derivatives are integral, they cancels, but not here because we have a standard derivative here, which is 1 divided by z square plus 4. But what should be the answer for this if you integrate this? So here is the trick. If you have this expression, integral of let's say we have du divided by u square plus a square. So this is equivalent to 1 divided by a, tan inverse of u divided by a. So we have tan inverse of u divided by a. So here is the standard for it. And if you want to know how we prove it, so yeah, drop it in the comment section so that I can make video on it in the next class. So here by we have dz divided by z square plus if these two are 4, I write it as 2 square just to look like the standard one. And if you integrate this dz, we are going the x rather, we are going to have x then plus the constant of integration. And while for this side, by applying the formula above, we are going to have 1 divided by 2 tan inverse of the tan inverse of here is z divided by 2, everything equals to we have zx plus c. Then I want to cross multiply. I want to multiply everything by 2 just to have tan inverse of z divided by 2 only. And here we are going to have tan inverse of z divided by 2, everything equals to 2 bracket x plus c. And don't forget that the value of z here that we let above is 4x plus y. That is from the question. And by replacing it here, we are going to have the tan inverse of 4x plus y, everything divided by 2 equals to 2 bracket x plus c. And if you wish, you can leave the answer here. It is absolutely correct, and you can still simplify further. But let's simplify further and see how to make y the subject of the formula. If you take the tan of both sides, we are going to have this as 4x plus y divided by 2. Everything equals to tan bracket. If we create bracket and we expand this, we are going to have 2x plus 2c. And if you cross multiply as well, we multiply 2 through both sides, we have 4x plus y. Everything equals to, we have 2 tan bracket 2x plus 2c. If we make y the subject of the formula, we transfer 4x to that side with negative, and here we have y equals to 2 tan bracket 2x plus 2c, then minus 4x. But here, if you have this 2c, 2 is a constant and c is a constant, so I can let all this one to be a certain constant. I'm going to choose another letter, which is letter A, and I will conclude that the value of y equals to 2 tan then bracket 2x plus a minus 4x. And here is the solution to this problem above. And you should keep it in mind that where this a is known as 2c. Here is how to solve this beautiful linear ODE, ordinary differential equation. I hope you learned something today. If so, give a thumb up, and don't forget to subscribe to this channel and never stop learning.